Hello, welcome again. We are solving some conventional questions of refrigeration and air conditioning. The topic is air conditioning. Question number 61 from Engineering Services Mains 2023. A room is designed for air conditioning as per the following data. Room sensible heat gain 30 kilowatt. Room latent heat gain 10 kilowatt. Inside design conditions are 25 degrees Celsius DBT and 50% relative humidity. Outside air conditions are 40 degrees Celsius DBT and 27 degrees Celsius WBT. Bypass factor of the cooling coil point 1. The return air from the space is mixed with outside air before entering the cooling coil in the ratio 4:1 by V. Determine the following: 1. Apparatus dew point. 2. Condition of air leaving the cooling coil. 3. Quantity of dehumidified air. 4. Mass of ventilation air. 5. Volume flow rate of fresh air. 6. Total refrigeration load. Okay. So this is a psychrometric chart flash. So here locating these points on the psychrometric chart, outside air condition is your 40 degrees Celsius DBT, okay, and 25 degrees Celsius, sorry, 27 degrees Celsius WBT. So this is the point. So at this point, the specific humidity is about 0.0172 and enthalpy is about 85, and specific volume is these are the specific volume is about 0.9 0.912. Okay, so these are written here: 40 dBT, 25 WBT, omega 0.0175, H85 specific volume 0.912. Similarly, the point 2 with 25 degrees Celsius DBT and 50% relative humidity can be located. So 25 degrees Celsius and 50% relative humidity can be located. So this is the point. So at this point, 50 approximately 52.5 is the enthalpy, and specific humidity is 0.010. Okay, so 0.010, okay, and 50.8, and specific volume is 0.85. Okay, as return air and outside air are mixed in the ratio 4:1, so taking 4 kg of this inside air and 1 kg of outside air, and total mass then will be 5. So finding out the temperature after mixing, so that is 20 degrees Celsius. Now if we join these 2 points I and O, inside and outside, and mark approximately 28 degrees Celsius here, okay, then this is your approximately 28 degrees Celsius from here. Then we get this point 1. Okay, so this is the point 1, and this is the condition after mixing. So now we have three conditions: I, 1 and O. O is outside air, I is inside air, and 1 is after mixing. Now room sensible heat is given. Room sensible heat is given. So room sensible heat factor is and room latent heat is given. So room sensibility is 30 and room total room heat is 40. So 30 by 40 that is 0.75 is the sensible heat factor. So now from this point, from inside air condition, we can draw a sensible heat factor line, taking this as horizontal as 3 unit and vertical as 1 unit. So this is your sensible heat factor line. Okay. So this is the sensible heat factor line, and this is the point at which the sensible heat factor line is touching the saturation curve. So this point comes out as approximately 8 degrees Celsius. Okay. So now it is also given that uh, the the point one sorry the bypass factor is point 0.1. So bypass factor, for the bypass factor to be point 0.1, when the mixed air passes through the cooling coil, then uh, 10% of it will not be cooled. Okay, so it means if we start from here and go up to saturation line, then this portion should be 10% of total portion, or equal to bypass factor. Okay, so this should be point 0.1 and this should be point 0.9. Okay, this is point 0.1 and this is point 0.9. Okay, so this is your bypass factor line. This is your bypass factor, this is 1 minus bypass factor. So this is the point point 2 after this air is passed through the cooling coil. Okay, so now this is condition here is 10 degrees Celsius, and relative humidity is 90% approximately. Okay, or we can use this. Draw room sensible heat factor line from room condition. This line is drawn by moving 3 units left, 3 units, because sensible is 3 and level is 1, 3 units, and so we will go 3 by 3 in this and 1 unit in this. The unit may be centimeter. So this line intersects the saturation curve at 8 degrees Celsius. This line has saturation curve at 8 degrees Celsius. Now draw a line from point 1. Okay, now draw a line from point 1, cutting the saturation curve and passing through this line, I7.6 line or I8 line. The line is lined in such a manner that it gets intersected in the ratio of 9:1. So this ratio is 9:1 to give bypass factor 0.1. This line intersects the saturation curve at 7.6 degree, which is ADT, and the point 2 is going to represent the condition of air enter your room or leaving the coil in the is given by 28 degrees Celsius. T1 is 20 degrees Celsius and T2 comes out as 9.64 or say 10 degrees Celsius, and relative humidity is 90%. That we have obtained from graph also. So now third part is quantity of dehumidifier. It is sensible heat divided by Cp, that is, and heat taken is Ti minus T2. So Ti minus T2 is 25 minus 10, that is 2 kg per second. Quantity of dehumidified air is 2 kg per second. Okay. So next is mass of ventilation air. So total air is 2 kg, that is room air plus outside air, and the ratio of room air and outside air is 4. So I have not come to as 0.4 kilogram per second. And volume of fresh air is mass specific volume. Specific volume divided by mass is volume. Total refrigeration load is total sensible heat load, that is room sensible heat load, and outside air sensible room sensible heat load is given, that is 30, and outside air is 0.4 kg, and temperature difference between inside and outside is 40 minus 25, and Cp is 1.05. So room sensible heat load is this. Similarly, room latent heat load 10 is total heat load, latent heat load 10.4, difference of specificity, and 25